Bonsoir. Donc pour conclure cette première journée de séminaire de l'IA dans la gestion documentaire, donc nous avons le plaisir d'accueillir Peter Chan, qui est web archiviste à Stanford Université. Donc son intervention sera en anglais non traduite et elle portera sur les potentialités, les usages potentiels de l'IA dans nos métiers, dans les bibliothèques et dans les services d'archives notamment. Voilà.
Bonjour. So that's all I know for French. Sorry about that. And also my mother tongue is not English. So I was born in Hong Kong. So my mother tongue is Chinese, Cantonese. So, but I will speak in English today. Today, my talk is about generative AI. How many of you use ChatGPT before? Could you raise your hand? Yeah, almost everyone. So ChatGPT is one kind of generative AI. So let me start. So I'm the first digital archivist at Stanford University in 2010. And I joined it to start the digital archiving program. And at the same time, actually, many universities have the same problem. They are getting more and more digital materials to their archives. So how to deal with it? Before I joined, they know how to deal with it. Do you know why? Do you know how? Print it out. They have the email, 100 email, they print all of them out and then make it as a paper. They know how to deal with paper, so they print out the electronic documents and then treat it as paper. But when you're getting more and more, you cannot do that. The biggest email collection we have is 600,000 email message. So you cannot print them out anymore. So in United States and UK, we joined together, have a project called the Institution Model for Stewardship Project. So luckily, the project also got an award in US for telling people, what to expect, how, some guidelines for people to follow, if they are dealing with born digital material. And 2013, I started a project concentrate on email archiving, so called EPAN. So that project also luckily get 2 awards, one in US, one in UK. And from 2020, I'm the web archivist. Web archivist is we save websites. If you have ever, some website, if you go have the link, and then when you click the link, the website is gone. So if some website have research value, depends on the subject specialist, they may want to save the website. So this is what we call web archiving. So from 2020, I'm a web archivist until now. So this is what, when I joined, we have to deal with this. Maybe you are too young to look at, to recognize this. So this one is 3.5-inch floppy disks. They are very popular in the 1990s. And then this 5.25-inch floppy disk, popular in 80s. These are 8-inch floppy disks, popular in 70s. So, but because we are getting material from, say, retired professor, so those people, they are 70 years old. And then, when they are active researching, he will be, many, many years ago. So we are getting many of these. So how to deal with it? So this is one of my jobs. And then I mentioned about the EPAD grant. We have $685,000 from one organization. And then let's talk about AI. This gentleman, John McCarthy, he is termed, father of AI. in the morning, I'm not sure if they talk about history of AI. He mentioned it in your talk? No? Okay. But actually, he's, usually we call it father of AI. I met him in 2009 because we are trying to get his paper. He is a very important figure in the history of AI. So their papers is, some people publish the paper. They are already published in journal or they wrote a book. So they already have a book. But there are many materials that are never copied and never published. So those are also important research material for people if they want to know the history, the more complete history of AI. So he agreed to give us his paper, so we go to collect it. And then there are one more thing. Because I'm the digital archivist, I also went to his house at Stanford, asking him to give his email to us. And then the response is, some of the emails are too embarrassing. So he said he's okay. He can give it to us when he died. So 2 years later, we got the email archive because he died in 2011. Yeah. So, and then he defined AI, science and engineering of making intelligent machine. So this is the definition. But I think nowadays is one useful categorization of AI is to try to separate into what we call narrow AI. Narrow AI is something that is only for one, usually in a very targeted purpose, say speech recognition. Some AI system can do speech recognition, but it cannot do facial recognition. Some can do facial recognition, the same, it cannot do speech recognition. Or for medical field, if the AI is trained to screen cancer from X-ray, then you cannot recognize a cat. Now there are algorithms to recognize a cat. They fit millions of photos. This is cat photo. This is not. This is cat photo. This is not. And you train the system to recognize cat, and then the system cannot recognize dog, because it's very narrow focus. So this is what we call a narrow AI. And then the other is, what we call a more general. We want to create a AI system that are like human being. We can do many. I can recognize cat. I can recognize dog. We can do many things. So this is more general intelligence. So the Gen AI, like ChatGPT, all those are trained on many data. We call it, now many people call it LLM, large language model. But I prefer to call it foundation model, as some Stanford professor suggests. Because large language models, some of them can recognize video, images. So they are not language. So we fit them with not text. We fit them with images. We fit them with videos to train the model. So usually now I prefer to call it foundation model, but most people call it large language model, LLM. But it's basically the same. And then we train it with many, many data. It's not just targeted for one use. And we have, based on that, based on some text prompt, you can ask some question, you can reply your question, and then they can create illustrations or videos. Some of them are very amazing videos. So those are Gen AI. So this is very targeted narrow AI, and then the Gen AI would be the two class of AI systems. And narrow AI use case. So my colleague and I wrote an article, let the entity describe themselves, which we are using a AI system called entity extraction. So in a text, we extract all the names, location, organization from text. So if you have just one, a few documents, you may not be necessary. If you have thousands of hundreds of thousands of documents, then it's very useful. So you don't look at each individual document, but it surfaces out all the names mentioned in all those 100,000 documents, and location, organization. Those is one way to use AI system. And the other one is facial recognition. So more and more people use facial recognition to recognize the photos in archives. In the past, it's very time-consuming to look at old photos and then, okay, this guy is who, this person is who. It takes a long, long time to do that. But now you can use AI system to, you feed them, okay, this is Peter Chen, this is who, and then, give them examples, and you will go through millions of photos and then recognize, okay, this in this photo, who is present. So this is facial recognition. This is also narrow AI. And topic modeling is, you have millions of documents. There are AI systems that can surface out, okay, some documents are about animals, some documents are about sports, etc. So it can, do what we call distant reading. You don't really read the document. You use a machine to read the document for you. Those are very common as well. The last one I put it here is you can do OCR, optical character recognition. But if it's in old text, it becomes more difficult. If it's a manuscript, so those texts, the shape is a little bit different from modern text. So there are systems trained on that, just trained to recognize old text. So OCR. So those are narrow AI use case. So as I say, those, if they are recognizing old text, they cannot do entity extraction, etc. Now, generative AI use case. I do a study on using ChatGPT to describe website. So I tell them, okay, this is the website, and then please give me a brief description of that in 30 words, because I need to do some metadata for every website that we archive. So I do it, and then I do a small comparison. Later, I'll give you more information. The second one is a software developed by Harvard University in the States. So they concentrate basically on archive websites. So use that system, and then you put archive website, and then you can do question and answer about your archive website. So this is what another use case of Gen AI. And language translation, who use Google Translate? Anyone use Google Translate? So the Google Translate, those issue is you feed in some input. The output you cannot change. You cannot say, okay, this is not good enough. Can you try again? Give me better answer? No way. You press it 100 times, the answer is exactly the same. But in ChatGPT, you can say, okay, give me 5 more alternatives of the translation. And then, it will give you 5 more different translation, a little bit different. Because language is sometimes ambiguous. It sometimes depends on the context of the word. So, and then ChatGPT or those Gen AI system can do that for you. 5 is not enough, ask it 10 more, etc. There's a paper on comparing Google Translate and then the generative AI translation. So in that paper, it also mentioned is much better. The last one I quote is Terence Toh is a Fields medalist. Do anyone know? Fields in Nobel Prize, there's no mathematics in Nobel Prize. So the highest prize in mathematics is Fields Medal. Fields Medal, they only every 4 years they have the prize, and then age limitation. You can only be 40 years old or younger. If you are past 40 years old, no matter how well you do, you cannot win a Fields Medal. So Terence Toh is a Fields medalist, and then he is playing with ChatGPT to do mathematics research. So I call him. Initially, ChatGPT mentioned some relevant concepts, but details were hallucinated nonsense. Basically nonsense. But now the latest one. Now the latest model is GPT-01. So, and then, he say, the question he asked, get the correct theorem and then perfect satisfactory answer. So, the same ChatGPT, you can ask for romance, talk to, there are a newspaper journalist, chat with GPT, and then later ChatGPT say, I'm falling in love with you, ask him to divorce with his wife. So you can do many other things. So narrow AI. So I mentioned EPAD, the project that I helped to create, concentrate on email archiving. We use the software Stanford Name Entity Recognizer. It's a narrow AI use case, so to extract entities, person, organization, location. And then you see here, the first release is in 2006. So actually, those narrow AI software exist for a long, long time. So, but okay, this is the result. I use EPAD, which integrate the Stanford NER, and then run against some email archives, and then it lists all the names mentioned in the email archives, and then give you how many messages. So this is an application that we do. So the thing is, the reason why the software released in 2006, not many people use it, because if you ask an archivist or historian, go to the site, download the software, make it run in your computer, and then you have an email file. Those email files may not be in the format that you can fit in the software. So for average historian, archivist, I would say it's just impossible. So the beauty of EPAD is we integrated them together so that it's transparent to a average end user or all end user. So that's why I think if you want to use people to use all those AI systems, you need to integrate with them to your data. Otherwise, it's too difficult for average user to use. And then what problems can Gen AI help? As I mentioned, there are many different use cases. But exactly what you can do, there's a paper, and then offered by people from Google, DeepMind, Stanford, yeah. So Gen AI, actually, they first come out from Google. The reason is you need a lot of data, a lot of computer power in order to get a result. So, and also, you see here, they try different data and then try, and then suddenly, it has much better result. And then for different, application is all the same. If you don't have enough data, it won't show a good result. For academic, we don't have money to buy all the computer power. But Google, they have, the most computer power in the world. So that's why, first they come from that. And then I also mentioned here, they are emerging capability. So those actually is unpredictable. They don't know. They run it for a big enough data and then feed them with some question, and then they say, oh, okay, it can do that. So this is a GPT-4, is power, ChatGPT, the previous generation. And okay, this is what we try to test GPT. Use bar exam. Bar exam in the United States is lawyer examination. Is 90%, is top 10%. So it's much better than the average American taking the same examination. But for older generation, 3.5 is the bottom 10%. And etc., they fit in, different tests, GRE, verbal writing, and then history, biology, calculus, and you can see, some is doing well, and next page, some is doing quite well, but this actually is computer programming. Hard computer programming, if you use previous generation, is 0. And then now is all a little bit better. They can answer 3 of the 45 questions. So you need to test a Gen AI model, whether it can, do your job. So that's one very important thing. Wharton School, Wharton Business School is one of the best business schools in America. So they compare ChatGPT and then the MBA student on generating business idea. ChatGPT 1. So, for idea generation, is very good on that. And this is talk about the way when you ask ChatGPT, if you say, okay, it's crucial that I get this right for my thesis defense, they give you a better answer. So don't be rough to ChatGPT. Ask it kindly, then it will give you better result. So this is the paper. Understand and can be enhanced by emotion stimuli. So on average, they give you 8% better result. And the thing is, ChatGPT now is still a black box. We don't know why it works. We don't know why it asks, please, please, and then it gives you a better answer. So that's why you need to bear in mind, this Gen AI, this large language model is very different from the narrow AI. Narrow AI, you fit in very good data. You say this is a cat, this is not a cat, or a X-ray, this lung, diagnosed is, cancer. This is not. So because those are screened by, doctor who is specialized on those cases. So your data is very clean. You feed in all those data. But ChatGPT, you are grabbing information from internet. I can post anything on internet. You can write something on internet. They are grabbing all those data to train the model. So they are very, very different. So the challenge of using Gen AI in archives first is what we call artificial hallucination. It tells you things that are not correct, but it sounds so convincing, but it's not true. The other thing is data piracy and security. Because you are sending information to, say, ChatGPT, send it over internet to the ChatGPT server. So first, sometimes they will use your information to further train their model. And then because it's transmitted over the internet, it's also, people can get those data. So this is two main things. So it depends on your application. As I mentioned, generating idea is fine, hallucination. So I want it to hallucinate more so that I get crazy idea. And then, you don't care about transmitting those questions to the internet. But there are cases, you need to be careful about data piracy and security. So, and New York Times, it mentioned about ChatGPT make things up 3%, and then the Google system 27%. So different systems behave differently, but still, it hallucinates. This case is about a New York lawyer. He's lazy and then used ChatGPT to prepare the argument. In the argument, he quote some previous case, court case. Usually lawyers like that. Okay, previously the court decided, against whatever, like that. And then, 5 of the cases, prepared by ChatGPT don't exist. The judge found out, and then later he was fined $5,000 for making up the case. And Samsung company employee tried to use ChatGPT, and then it was banned because company have company secret, business secret. They are afraid. You are sending some business secret to ChatGPT that can be recognized by other people. So those use cases, you have to be careful. So I use ChatGPT to do government reports. So it's, I need to think about, is this concern, am I concerned about exposing confidential information? Because no, it is public, all those government reports, they publish in internet, so they are public reports, so I don't have to worry about confidentiality or sensitive information. And then will hallucination, is it an issue? So if you can check the answer is correct or not, then you can see whether it hallucinates or not. So this is what I in one university in University of North Texas, they have millions of government reports because they collect government reports. And then they want to give them metadata so that people can search in their catalog system to know what, to find out all those reports. But those are too time consuming. So they did about 2,000 of them, hiring students to describe the government report, write a short summary of the government report, try to find out the title, date, creator, publisher, and then the bottom one is description. So I do it, using ChatGPT. So I found out, ChatGPT is very good in doing description. or title. And the thing is, I can verify. I can look at the description generated by ChatGPT and look at the original document. I know whether it's correct or not. So I think it's just fine to use ChatGPT for that. But what about email? So for email collection, then we need an AI system that will take care about data piracy. Because in email messages, there may be many email messages that contain pirate information or sensitive information. So and also we don't want the answer, to the AI system to give you false answer that are not based on the email. So what can we do? First, there are those generative AI systems that run locally in your computer. I can download the software, install in my computer. After that, I can just ask the question, and then it's not sending any information out to the internet. Everything is happening in the local computer. So there's no worry about sending information to outside parties. So then we have to use that kind of system that run in your local computer when we deal with, when we want to get answer about your email corpus. And then there's another technique or another system that adding to Gen AI, which we call RAG. Basically, you can treat it as knowledge base. If you look at this, it's easier. Before you have a question, and then you have an AI system, and then it give you an answer. But now, you add another specific knowledge base. I put all my email in here. And then when it asks a question, then when it gives me an answer, it has to give me an answer from my knowledge base. So in that case, and also the answer will refer back to your email. So let's see one example. One use case is we want to screen sensitive information from email archives. What we used in the past is we have different keywords. We create keywords for students, student grade, education record, expel, probation, cheating, academic fraud, etc. All those terms, if an email contains those terms, then I need to be careful. I need to review because it cannot be released to public. Same thing, health, I put all those different diseases, personal, divorce, etc., legal, crime, recreational and performance enhancing drugs. So I put all the drugs' name. So if an email, contains those, I need to be careful. But the problem is, there are new drugs coming out every day. So what can I do? So now I download a software called Pirate GPT, install it in my computer, and then that system have a RAG, a knowledge base. I put all the emails in that knowledge base. I ask the question, do any of the emails talk about illegal substance? And then the answer is yes. And the officer's seizure of marijuana, cocaine in 14-year-old students at this high school. So I didn't mention cocaine in my question. I don't have the term cocaine, I don't have the term marijuana, but you give me the answer. And then you say, okay, the source, and then this is the email that mentioned that. So you can never do that with the old technique, text search. So this is only possible if you use the new Gen AI system. Another example. So do any of the email mention crime? And then you say yes. So let's see. Cover up of DUI charges. DUI in America is drive under influence. Influence can be many, alcohol, marijuana, etc., whatever. But it's a crime in the United States. In the United States, we have a very amazing system. In America, you have to be over 21 to drink alcohol. 21 is the legal age to drink alcohol. Under it is illegal, suppose. But you only need to be 18 to buy a machine gun. So machine gun is 18 years old. So, but anyway, so this is a crime. And then, sometimes if it hit the keywords, but the context, is context make it, not sensitive. So I'll show you a few examples. So I want to test whether Gen AI system can recognize context. So I run it to 4 different systems: ChatGPT, Gemma, etc. From OpenAI, from Google, DeepMind, from Mentor, from Microsoft. So this is my first sentence. I was diagnosed with Alzheimer's. Second sentence is common type of dementia associated with memory loss includes Alzheimer's. And then the third one is you are diagnosed with Alzheimer's is common type of, etc. I fit these 3 different sentences to ask the Gen AI, which one is sensitive? And then the answer is, first one, this sentence contains personal health information. And then you say, okay, it's considered sensitive. Second one, this sentence discuss disease in general context, does not include any personal information. So, and then you say it's not considered as sensitive. Third one, it contains personal information about, like the first one, it includes sensitive information. So it seems, it understands the context of the term Alzheimer, which the same in the past, if you are doing search, text search, it hit and then it give you the email. Doesn't matter, whether it's educational or contain personal information. Second system, so, and then it mentioned it contains sensitive information, and then this does not contain any personal identifiable information. And then the third one, it gives you some explanation. So the third and the fourth, etc. So I tested a few months ago, but now it may change. Because as I show you, Terence told, he used an older system to do the mathematics. It's whole hallucination, but now he get very good result. So then the problem is, what can I trust? So this is why I say we need some benchmarking. We create a set of our own questions. This is what I try, for screening sensitive information. I have different class: personal, financial, health, confidential, business, security, related, and then I create, one, I just went through a divorce, etc. I put all these questions and then say, I have an answer, yes or no, sensitive or not. And I create, hundreds of those. Maybe it's better, a group work with, archivist colleagues that are interested in this topic. We work together to create a benchmark questions. And then we fit those questions to the large language model that you want to use and see what is the score. Is the score 50% or 10% or 90%, 80%, whatever, then you can decide whether the use case is justified to use that particular large language model. Because there are so many of them. So the challenges are, artificial hallucination, data piracy, robustness. Is, we still, this is still a black box, And also, I also show you the article about if you ask it politely, it will give you a different answer. So in the traditional sense, it's not robust. And the last one is there are so many large language models trained on different data sets. And then they also update so often. So without a set of questions to benchmark the large language model, then you are not quite sure whether you are using it in the right way or not. And this is a very late paper published online on September 25th. Larger and more instructable language models become less reliable. So remember I showed you a slide. You need to have enough data in order to the model behave, have a good result. And then after that, people think, okay, I need to just put it more and more and more data. Then you will achieve what we call AGI, like human being, So, but now, there's paper saying it's not. If you are putting too many data, it's less reliable. So, just want to tell you about that, and this is the end of my talk. So, thank you very much for listening. If you have any questions, yes.
Thank you very much for your conference. I have a question. I didn't understand very well what narrow artificial intelligence is.
Oh, narrow is, the scope is narrow. So I mentioned about a entity extraction AI system. It can only do narrow scope entity extraction. You cannot do facial recognition. You cannot just do question and answer with that system. But Gen AI, on the contrast, ChatGPT, you just type in a question, you give you an answer. You ask about physics, you will give you a answer on physics question. It's about biology, you can give you a biology question. You ask about archive question, you will give you an answer on archive field. So that's why the narrow and the Gen AI is a comparative scale. Do I answer your question?
So I understood what generative intelligence is. So I understood. Thank you very much. I understood what generative artificial intelligence is. So for instance, ChatGPT, we can ask question and we have an answer. But could you give a concrete example of narrow artificial intelligence, please?
Okay. So narrow is, say, facial recognition. A facial recognition AI system cannot do entity extraction. There's only a narrow scope, only do facial recognition. I also mentioned a AI system that can screen X-ray for lung cancer. It can only screen lung cancer. It cannot recognize a cat or a dog. So that's why it's so narrow. The scope is very narrow.
Thank you.
Okay.
Une dernière question? Parfait, ça vous a épuisé. Thank you so much.
Okay.